The angle of elevation of the top of a flagpole is 42 degrees from point P, which is 180 meters from the foot B of the flagpole. Q is a point on the same horizontal line BP such that BP is 45 meters. We were told to calculate correct to one decimal place the angle of elevation of the flagpole from Q. Now this problem falls under angle of elevation, and by definition the angle of elevation of one point from another, it is the angle between an observer's eye and that of the point at which he looks above the horizontal. So the angle between the horizontal line from an observer's eye to the point at which he looks above the horizontal is called the angle of elevation. And we want to provide a solution to this particular question. So let's begin. The first thing we're going to do, we're going to draw a diagram to represent the information on the board, and we'll use trigonometry to find the angle of elevation of the flagpole from Q. So let's go. Now we have the angle of elevation of the top of a flagpole. So we locate the flagpole. So locating the flagpole, we say this is the flagpole. This is the flagpole. Now the angle of elevation of the top of a flagpole is 42 degrees from a point P. So we are going to locate the point P on the horizontal. So this is the flagpole, and this is the point P. That's point P, and this is the flagpole. Now, after doing that, we have to see that the angle of elevation is 42 degrees. So from at point P here, the angle is 42 degrees. Great. From point P, which is 180 meters from the foot B of the flagpole. So the distance from point P to the foot of the flagpole is 180 meters. That's 180 meters. This is the distance. Now the foot of the flagpole is at point B. So we'll put B right here. Point B. Good. So 180 meters from the foot of the flagpole. Q is a point on the same horizontal line. So on the same line, there is a point called point Q. BP. So BP is this horizontal line and Q is a point on this line, such that BQ is 45. So we know BP to be 180. So BQ should be 45. So this line should leave from here, and that will make BQ. So we say this is point Q. So BQ will be 45 meters. BQ is 45 meters. Great. We are told to calculate correct to one decimal place the angle of elevation of the flagpole from Q. So this is the flagpole. We are told to calculate the angle of elevation of this flagpole from Q. So we call that angle theta. Good. So what we need to do here is to represent the top of the flagpole with a point, and we call that point A. So I'll call that point A, and then to find this angle, I will need to use this angle along with the other information given. So what I'm going to do here, I'm going to say that H is the height of the flagpole. So AB is H. And then I'm going to look at, because there are two triangles here, triangle APB and triangle AQB. So I'm going to say from triangle APB, from this larger triangle, what happens? This angle, this is 42 degrees, and I have the height, which is H, and I also have the adjacent side to 42. So according to trigonometry, what is opposite or adjacent? Opposite or adjacent is tangent. So I'm going to use the tangent function to find H, because I already know the adjacent. So tangent of 42 degrees is equals to H divided by 180 meters. And that's what you are going to have. Now, if I cross multiply, I will have h is equal to 180 meters tangent of 42 degrees. So h is equal to 180 meters tangent of 42 degrees. And if you take a calculator and multiply 180 times tangent of 42, you should get 162 meters. So h is equal to 162 meters. Great. After that, we will need to consider this smaller triangle. Remember, this is a right angle. So the angle between the ground and the flagpole is 90 degrees. So this small triangle is triangle AQB. So from triangle AQB, what do we have from triangle AQB? We have this AQB. So this angle is theta. So we have the opposite side and that of the adjacent side for this triangle. So we have tangent of theta to be equal to h divided by 45 meters. Good. We do not have theta, but we have h. So tangent of theta is equal to h is 162 meters all divided by 45 meters. And you observe that meters and meters will cancel out, and then you have tangent theta is equal to 162 divided by 45. To solve for the angle theta, we take tangent inverse on both sides. So we have tangent inverse of tangent theta is equal to tangent inverse of 162 divided by 45. This is how we're going to have. And if you take the inverse function of the function itself, when you do composition of function, f inverse of L of x is just x. So this entire side is just going to give us theta. Theta is equal to, and if you use a calculator and find tangent inverse of 162 divided by 45 and convert the answer to 1 decimal place, you should have 74.5. So theta is 74.5 degrees to 1 decimal place. And that is the solution to this question. Thank you very much for watching, and we hope to see you in our further videos.